So with elimination, remember that you want to have the same coefficient with opposite signs. However, it doesn't always happen that way with all of the equations. Think about all the equations you've seen in your lifetime, and two of them may not have the exact same. However, they can still cross and have a solution with the systems of equations. So if you'll notice here, we'll look and see what we need to do, sometimes to one equation and sometimes both equations, to make them have the same coefficient, and all of it very mathematically legal. I promise I'm not making up. I'm not doing, I'm not a math magician, okay? This is all real math. So let's first example, we have 3x plus 2y equals 2, and then our second equation is 2x minus 4y equals negative 36. Now, there is actually lots of different ways you can go through and approach this, but notice that the coefficients in front, or our signs in front of y, are opposite. So I'm going to make one of those equations make them have the same coefficient. So when I go through and add, I go back through and make them have the same. That way I can add them together and they eliminate, because that's really fun when they have the same coefficient. So what we're going to do here, we have 3x plus 2y equals negative 2. So I'm going to make that. I want this 2 to become a 4. I want that 2 to become a 4. Well, in order to do that, I'm going to have to do something. I'm going to have to multiply by 2. So it's a multiplication. So you're not looking at adding. You're going to have to multiply, because you're going to multiply everything by it. So if I multiply this whole equation by 2, guess what? That makes that 2y become a 4y. So I'm going to come down here. So that makes 2 times 3x is going to be 6x. 2 times 2y is going to make a 4y. And then 2 times 2. So yes, even across the equal sign, it's going to be a 4. Positive 4. So now you'll notice, same coefficient, opposite signs, I can go through and eliminate. So I'm going to add the two equations together. So I have 8x is equal to negative 32. So those eliminate. Now solve, divide each side by 8. And so x is equal to negative 4. So now, again, go back and plug it in. But now you have 3 equations. You can use the original equation, you can use the original second equation, or you can use that equation that we came up with, so that way we could eliminate. I'm going to use the top equation. So I'm going to go back. I'm going to plug in negative 4 for x in here. So I have 3 times negative 4 plus 2y is equal to 2. So I'm going to simplify. So that's negative 12 plus 2y is equal to 2. Add 12 to both sides. And so 2y is equal to 14. Lastly, you want to divide by 2 on each side, so y is equal to 7. And then writing this as an ordered pair, negative 4, 7. All right, so here we're going to have x plus 5y is equal to negative 21, and negative 2x plus 6y is equal to negative 38. So you'll notice that I have opposite signs in front of my x's. So I have a positive x and a negative 2x. So what I can do is I'm going to make that be the same coefficient, because they don't have the same coefficient right now. Remember that I have a coefficient of 1 in that top equation. So I'm going to multiply everything here by 2. So that makes 2x plus 10y, and even across the equal sign, is equal to negative 42. Now, same coefficient, opposite signs. I can add these two equations together. So that eliminates my x, and I'm left with 16y is equal to negative 80. And then lastly, I'll divide by 16. And so y is going to be equal to negative 5. So then I can take my negative 5 and I can plug it into any equation I want. I'm actually going to plug it into the top equation again. So I'm going to take this negative 5. I'm going to plug it in for y, because that's what y is equal to. So I'm going to have x plus 5 times negative 5 is equal to negative 21. And then x minus 25 is equal to negative 21. So add 25 to both sides. And so x is equal to 4. So then finally writing this as an ordered pair, remember x comes first, even though we solved for that second. So we have 4, negative 5. That would be my solution. Where those two, remember where those two lines meet. And then for our last example here, you'll notice we have 5x minus 3y is equal to negative 19, and then 6x minus 4y is equal to negative 26. So what you'll notice here is that I don't have opposite signs in front of any of my coefficients or any of my variables, and I don't have the same coefficient. So I get to pick which one I would like to eliminate. This time I'm going to pick the x. You could pick the y. It doesn't affect the outcome of the solution at all. So I'm going to multiply this to make it be a coefficient in front of x, that way I can eliminate both of them. So I'm going to multiply by 6. I multiply everything by 6 here. So I'm going to write this one on this side. So I have 30x minus 18y is equal to negative 114. And then I'm going to multiply the bottom instead of multiplying it by 5. So where did I get those two numbers from? That's just the opposite. It's just the coefficient in front of the other in the other equation. So I got 6 because I used this 6 right here, and then I'm going to use 5 because of that 5 right there. So not only, but I also need them to have opposite signs. So I'm going to multiply by a negative 5. So you only do this because they have the same sign in front of them. So I'm going to multiply by negative 5 everything. So I have negative 30x plus 20y is equal to positive 130. So from here, I now can add the two equations together because I have opposite signs and the same coefficient. So I'm going to add those two equations together. This gets eliminated. I'm left with 2y is equal to positive 16. And then I'm going to divide by 2. And y is equal to 8. Now I can take that y and I have 4 equations now that I can go back and plug it into. I'm going to choose ones with the smaller numbers. That's just me. So I think I'm going to use, I'll use the second equation here. I'm going to plug it into y there. So I have 6x minus 4 times 8 is equal to negative 26. And then I have, 6x minus 32 is equal to negative 26. Add 32 to both sides. And so 6x is equal to 6. Then divide by 6 on each side, and x is equal to 1. So writing my solution is 1, 8. Ooh, that's about 8. One comma 8. So that's where those two graphs would cross. So remember, just some final things is that with this elimination, remember you may have to change the signs and that would be changing the signs of everything because you want them to have opposite signs, and you may have to change the coefficient. And I do that by multiplying. So I'm going to change a coefficient by multiplying, and I usually multiply by the number that's in front of the same variable in the other equation. That's typically the number I'm going to look for to multiply by. All right, so this is it. This is the elimination, the part 2 part. So remember, the only difference here is that you may have to change the signs by multiplying by a negative number, and you may have to change a coefficient by multiplying by the coefficient in front of the same variable that's in the other equation. And that's it. This is elimination. This is the last tool in your tool belt for solving systems of equations.